Okay, so now we want to finish up this left-tailed test before we can head on to greener pastures. So we need to find the p-value using the function probably most of you have, which is t-dist. Now the thing about t-dist is that it wants a positive x value. So you're going to have to take the absolute value of that test statistic, and then you're going to have to tell it the degrees of freedom, and then you're going to have to tell it one-tailed because it's a one-tailed test. And there you go. So t dot dist works really great. It can handle the negative value for the t function. T dist, the old one, won't be so nice. You'll have to take the absolute value and then tell it it's a one-tailed test. All right, so there we go. So we got our p-value method. And then step 5, let me put it over here. Step 5, if you do classical method, you would say reject H0 because T0, which is negative 2.23, is less than T alpha, which was equal to only negative 1.943. Or you can say reject H0 because your p-value, which was 0.0336, is less than alpha, which is equal to 0.05. I personally prefer the p-value way, but one way or another, you have to know that you have to reject. Okay? I personally always like double checking myself with StatCrunch because I just think it rocks. So, oops, wrong thing. That's my YouTube channel. All right, so let's go here. Stat T statistics. This is paired data. So let me click on that. I have it in X1 and then I have it in Y1. Right? And then I can save the differences if I choose, and that'll pop it into that third column. Next. All right, I'm not making a confidence interval. I'm making a hypothesis test. I'm not doing a not equal to test, though. I'm doing a less than, right? I want to know, was X1 less than X2? In other words, when you take, I better write it out. Hold on one second. There we go. So if you look at your null and alternative hypotheses, matter of fact, I'll put them up here next to the hypotheses. You're trying to figure out, is X1 minus Y1 less than 0? In other words, is X1 less than Y1? So let me go back to my thing. Oops, my Java. Here it is, right there. So it's a less than. And then I calculate. And there you go. See, the same test statistic we came up with. Negative 2.23, and the p-value is 0.0366. And I'll put that right here. And I can see it. Awesome. And it backed me up. And then I'm not going to do the confidence interval because I've already shown you guys how to do that. It's pretty straightforward, and you've learned it in other videos, both with Excel and with StatCrunch. All right, now what I will want to do is start on the next one, which is going to be number 15, which is a right-tailed test. And luckily for me, I can get the data rather simply from StatCrunch or from the Excel video or the Excel disk if I happen to have it. So I have this data. I'm going to take it back in and import it into Excel. There we go. All right, so now this is talking about, let's see, the Secchi disk being put into, it's on page 591. They're trying to measure the cloudiness of a lake, right, at Joliet Junior College. They've got the results, right? So when we go over here, we can see that it's initial depth and then depth 5 years later. And it's at the same locations on these same dates. So May 11th, one time, and then 5 years later. So why is it important to take the measurements on the same date? That'd be your first question. And think about it for a second. I'm not going to write it up, but you would write something to the effect of, you're trying to account for confounding variables, right? So time of the year, that kind of thing, you want to make it exactly the same. That way you can't say that time of year was affecting the cloudiness of the lake. It's all that chapter 1 stuff with confounding variables.